Well, we remember to record today.
Yeah.
All right, how is everybody? Oh, we only have 11 people, so we might want to like.
Oh yeah,
take
we can wait a little while.
You did gymnastics for 2 years. Oh, I mean, 2 years is a good. Oh yeah, I remember. I forgot.
Fun fact, I actually also danced for a little while. I did a lot of different things when I was little, but I like stopped.
Started with 10. Okay, so I played soccer a lot until I was like 8, and then I
played soccer too.
I played soccer a lot, and then I moved and I played tennis for 2 years. And while I was playing tennis, I also swam for 2 years. And then after I swam, I got into basketball, and I played basketball like pretty much every day since
Does
sixth
doing
grade.
like softball over the summer at a summer camp count?
Okay, and then after I got into basketball, and I'm still into basketball, I got into football. Been playing football for 3 years, and then I played golf for a year. That's about it.
Yeah. I just realized how many different things I've like done.
Oh, you play
like
guitar?
quit.
You play guitar? I've been playing guitar for 8 years. Very interesting.
Yeah, I really like this comic.
For 8 years.
I read Calvin and Hobbes. So
Calvin Hobbes. Who's Calvin Hobbes? Is he like a
Calvin and Hobbes? This is the name of the comic.
Oh,
Calvin and Hobbes.
Interesting.
Okay.
Does anybody play? Okay, how many?
There's only like 13 people, so we're still missing like.
All right, we'll wait until 35. Okay. I think that should be sufficient. Does anybody play any instruments?
I don't I kind of play piano now. I don't know. I kind of quit a lot of things. I don't know why.
You used to play guitar.
Oh,
we have a lot of guitar players. Interesting.
Oh, wow.
You quit? That's fine. I don't really play as much anymore. I don't really have that much time to take voice. I know somebody that takes voice.
Oh, nice. Violin and piano.
You use YouTube for guitar lessons? Yeah, I teach myself now. I don't.
Yeah, I play bits of piano. I don't like. I can play songs, but I don't really. I just sort of freestyle my way through a song.
I can play once you learn one instrument, learning other instruments is so much easier.
Yeah, I agree.
Like I learned a song on violin in like 7 minutes.
I mean, for me, when I play piano, it's no longer like looking at like a note sheet and doing like learning how to actually play a song that's already written. I just make my own songs and just make them up on the spot.
How many? Wait, we have like 4 people that play guitar. Oh Lord, wait, and then but harsh quit. Okay, it's fine though.
Okay, well, no one else is coming, so maybe we should just start.
Yeah, we'll just start.
All right. Today, as you can probably see by the title, we're just focusing. Oh yeah, there's another person. We were talking about sports, and then we got into what instrument you play, and now we're starting the lesson. Yeah. So today we're going to be learning about triangles. Also, I'm a little bit tired, so yeah. Okay.
Also, I think Amy, I think we should speed through the more basic stuff like what is an
we can go
just because the rest is very, very important.
Yeah. All right. So, okay. Homework review. So, this first question, Marjorie's winning art design is shown. The smallest circle has radius 2 inches, with each successive circle's radius increasing by 2 inches. So, what percentage of the design is black? And I would have asked for your answers, except it's kind of 41.7 would be fine. I would have asked for your answers, except it's already on here. So I think I'll just explain then. So the inner circle, first we find the total area. So that would, yeah.
I did my homework, but I forgot to turn it in. I'm sorry about that.
Oh, that's okay. You could just turn it in right now. If you need to.
Let's do that. Yes. Can you schedule it?
Oh,
Might want to mute.
Tuesday. Let's put Tuesday.
who is okay?
That should be good. Yeah.
I can. Okay, I'll mute there. All right. So the total area of the board is has a radius of 12 inches. So it would have an area of 12 squared times pi, which is 144 pi. And then we find the area of the black region by adding up the areas of the circles which are supposed to be black and subtracting out the areas that are supposed to be white. So so we would start off with the radius of 2-inch area. So that'd be 2 squared.
No, 42 isn't wrong. Sorry, 42 isn't wrong. It's fine.
2 squared pi, and then we add the radius of 6 inches, so it'd be 6 squared pi, but then we must subtract this white area, so it would be minus 4 squared pi, and then we add the radius of 10 inches, so it'd be plus 10 squared pi, and now I'm running out of room, minus 8 squared pi. Basically you evaluate that equals 60 pi. And so this represents the area that is shaded, that is black. And this 144 pi represents the area that is not, well, the total area. So the percentage would just be 60 over 144, and you turn that into a percentage. So that'd be 41.6%, 67%, if you want.
Would 42% work, or
Since
since I got the same answer, I just rounded out to row 5.
I think that's fine. Just in the future, if you have decimal places, you may want to round to either the tenths or the hundredths instead.
Okay.
Usually it's the hundreds from what I can. Usually in like math counts and stuff.
Yeah, they like hundredths. Okay. Oh, okay. Let's erase that too.
Okay. Shall I explain this question?
Sure. Go ahead.
Wait 1 second. Okay. Actually, you do this one. I'll do the next one.
Okay, I can do this one. So for this one, a rectangle with a perimeter of 176 is divided into 5 congruent rectangles. What's the perimeter of one of the 5 congruent rectangles? So for this one, let's use variables to represent the side lengths of one of the rectangles. So we can call the shorter length of one of the rectangles x just because. So then we can also call the longer side length of one of the individual rectangles y. So this would be y and y. So basically, let's just mark all the side lengths around the rectangle. So now basically what we have is that we can actually set up some equations. So 3 of the x lengths is the same length as 2 of the y lengths. So let's write 3x equals 2y, or in other words, x plus x plus x equals y plus y. So then the total perimeter is just you add up all of these, and that should equal 176. So there are 1, 2, 3, 4, 5 x's. So we could say 5x plus 4y equals 176. And so now, since we have 2 equations, we can solve for the variables. So for this one, I think I'm just going to use substitution. So if we multiply both sides of this top equation by 2, then we get 6x equals 4y. And since there's a 4y in this bottom equation, we can substitute the 6x in for it. So we get 5x plus 6x equals 176, that's just 11x. So that means x equals, actually, I have no idea if this is the most efficient way to do it, but this is how I would do it. X equals 16. So then we can put this back into this equation up here and solve for y. So y would be 24, I think. So that means the perimeter of one of the 5 congruent rectangles would be x plus y, which is 80, just like a lot of you guys got in the chat. So good job.
All right, nice.
Okay, Rashad, you could explain that.
Yeah, okay, wait 1 second.
I'm
Okay.
erasing.
Yeah, that's a good idea. All right, I haven't solved this question, so I'll just do it now. All right, shoot, I'm gonna erase this. All right, that should be fine. Yeah. Okay, so in the staircase shaped region below, all angles that look like right angles are right angles. Okay, and each of the 8 congruent sides marked with a tick mark have a length of 1 foot. If the region has an area of 53 square feet, what is the number of feet in the perimeter of the region? Okay, so actually, I'm probably gonna get rid of these lines just because I don't want them.
Yeah, you can erase those.
All right.
Well, some of the lines aren't erasable though. So
Okay, it's fine.
Yeah.
Okay, so we can solve this one of 2 ways. We can solve. Oh, actually, I think those lines were good to keep. Okay, so it tells us that each of these are 1. So the area of this is 1, and so when we draw this, the area of this is going to be 2, and then the area of this is going to be 3. The area of this is going to be 4, right? So, wait, I have something in the chat. All right. So, 1 plus 2 plus 3 plus 4 is what, like 10, right? So now we have this like big rectangle after we draw these in, and so the area of this big rectangle is 53 plus 10, which is 63, right? So 63. So since the area of the big rectangle is 63, we know that this is 7. That's a very big 7. Like this whole thing is 7. I'm gonna make it a smaller 7 because 63 divided by 9 is 7, right? Okay, now I think we don't need these lines anymore. All right, so now we're gonna try to find the perimeter of this entire thing, right? So we already have 7 plus 9, so 7 plus 9. I'm gonna write that right now, and then I'm gonna also add all of these ones. So we have 1, 2, 3, 4, 5, 6, 7, 8. All right, so we have 8 ones, 8, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, yeah, 8. Okay.
Rashab, you don't need to do that.
What? Do what?
You can just notice that all the vertical lines are add up to 7.
All the vertical. Oh, you're right. Oh God. Yeah. So it's just 7 plus 7 plus 9 plus 9, right?
Yes,
Yeah.
it's because
So,
all of these.
yeah. Okay, that makes sense. Oh shoot.
Yeah, I'm just gonna show it though.
Yeah.
All of these vertical lines perfectly line up with the side that has a length 7, which means that the sum of all of these vertical lines is 7. And the same logic goes for all the horizontal lines. So all of
Yes,
these
then we have
horizontal
28 plus
lines,
18. Or no,
Yeah.
14 plus 18.
yeah,
And that's 32. 32. All right. Can I do the next one?
sure.
Oh wait, no, you can do this one. I want to do the ABCD one.
Oh
That's
yeah.
the
Okay.
one.
You can, oh wait, let me
Like,
just
can I
erase
erase all
some of the stuff on
print on
this
it?
side.
I'm gonna erase all the
Yeah, you can do that.
because
This was shiny
I don't-
stuff.
I don't want the answer to be there.
Well, I kind of already switched the slides, so
Oh
that's
God,
okay.
it's fine.
That's okay.
I erased the answer.
It's not showing up on my screen. You know what? I'm just gonna erase it on my screen too. Okay, so for number 4, in the diagram below, an equilateral triangle is inside of a square with side length 8. On one of the sides of this triangle is coincident with the side of the square. Find the area inside the square but outside the triangle. So basically, the area that it's looking for, let me just highlight it because I like highlighting, is like this area here. So in order to find that, we have to first find the area of the square, and then we subtract from that the area of the triangle. So first of all, since we know the side length of the square is 8, that means the area of the square is 8 squared, which is just 64. And then since the side length of the square is the same as the side length of the equilateral triangle, that means the equilateral triangle also has a side length of 8. And if you remember our formula for finding the area of an equilateral triangle, that is the square root of 3/4 times the side squared. So if we substitute 8 for the side, length, then we get side squared is 64. So 64 squared to 3 over 4, that's just 16 square root of 3. 16 square root of 3, that's the area of the equilateral triangle. So now what we do is we take the area of the square and minus the area of the equilateral triangle. So 64 minus the square root of 3. And that is just our answer.
What?
Is there something
I
you're
did. No,
confused?
I understand, but I did. I forgot to square a.
Oh, okay, yeah. That's the tricky part.
You can
It's
do
pretty
that.
easy to forget.
Yeah, it's side squared.
Yeah.
So. All right, next question. I really like this question. This is a great question. Okay. So ABCD is a square with side length of 16. Half circles are drawn inside the square with BC and CD as diameters respectively. Find the area of the shaded region. So a lot of people, what they'll do is they'll find the area of both of these semicircles, they'll add them, and they'll subtract it from the square. But the problem with that is this region right here, it's you're counting that twice, kind of. Does that make sense? It's like overlapping, right? So what I would do is, and use a blue one, draw this line right here, right? And then draw this line right here, and then this line right here. Okay. And we know this has a side length of 16, so this is 8. This is 8. And same for both of these, right? So now it's much easier to find the area of this entire thing, because now we have we have a square, and we have 2 quarter circles, which makes a semicircle, right? So the area of this square is what? 8 times 8, which is 64. Right. So by square, I'm talking about this.
I shaded it.
Yeah, the square, right? Oh shoot, I shaded it too. Okay, it's fine.
That's okay.
You see the square. And then we also have 2 quarter circles. So 2 quarter circles just makes a semicircle. And so that means it's plus 32 pi, because the area of the full circle is going to be, it's going to be 64 pi, because the radius is 8. So the semicircle is going to be 32 pi. And then the area of the full square, because we're looking for the shaded area, it's going to be 256, right? Yeah, 256. Oh, that's a bad 5. 256. So now we just do 256 minus 64 plus 32 pi, which is, what's that, like 192?
Yeah.
Yeah, 192. 192 plus 32 pi.
Minus 32 pi. They're in parentheses.
Oh yeah, minus 192 minus 32 pi.
So that I think this is a really good problem because it illustrates something about geometry problems. For one thing, there's usually like multiple steps needed to get to the answer. It's not just going to be like one straightforward thing. Also, you need to use a lot of different formulas. Like, I mean, not necessarily formulas, but you need to pull from a lot of different. You need to find the area of the squares. You need to find the area of circles, and even then, it's not even a full circle. Yeah. Also, I think this problem is really nice because it looks kind of tricky at first, because you might be thinking to yourself, how do I get the area of this weird shape over here? But in reality, you just need to draw some lines in the diagram to split it up into parts, which makes it easier to find the area.
Yeah, like I don't know if you guys remember or not, but yesterday I gave you 3 main tips for finding areas of obscure regions. 1 is draw random lines. 2 is, if it's a curvy region, it probably involves something with circles. And then 3 was what was 3? I forgot 3. Oh yeah, you're probably gonna have to use multiple formulas. And so this problem was a great demonstration. And don't be discouraged if you couldn't solve it, just because these problem solving skills will come with practice. So the more problems you'll solve, the better you'll become at, questions like this.
Yep. Also, I think I remembered, I feel like this was a math counts problem.
It's a math problem.
Yeah, I remember not being able to solve it when I first saw it. I like tried a bunch of things, but I couldn't
I
solve
think
it.
I saw this in 6th grade and then then I got it wrong because I was like clueless because in 6th grade I didn't really know much.
Yeah.
But Ishani was pretty smart in 6th grade. So I asked Ishani and then Ishani was like, oh, you do this and this. And I was like, oh wow.
Yeah.
Yeah.
Okay. So we can go through this for a little bit more quickly, but if you do have any questions, you can just ask. Oh, one more thing. We're still doing the point system. The point competition is still on, and it's kind of close. So
It's very close. We have a 4-way tie.
yeah. Okay. First topic of the day, the different ways you can classify triangles. Hopefully you guys already know it, but in case you don't, here they are. So first way to classify triangles is using the degree of the angles in the triangles. So there's 3 types: right triangles, obtuse triangles, and acute triangles. So basically, right triangles have one right angle, and a right angle is equal to 90 degrees. And the 90-degree symbol is this square thing, and it marks which angle is 90 degrees. Obtuse triangles have an angle that's greater than 90 degrees. So if a triangle has one angle that's greater than 90 degrees, it's going to be obtuse. And finally, acute angles are triangles that have all 3 angles less than 90 degrees. So those are the 3 ways you can classify triangles based on what angles they have. The second way to classify them is based on the different types of side lengths they have. So there's equilateral, isosceles, and scalene triangles. So equilateral triangles have 3 equal sides, which also means they have 3 equal angles, although that's kind of just a side effect of them being equilateral. Also, these tick marks, you see these lines, those lines mean that these sides are equal. And so since there's only 1 tick mark on all 3 sides, that means that all the sides that have 1 tick mark are equal. Also, these angles, the symbol for the angles, that also means that these 3 angles are equal since they all have one of those angle markers. The next type of triangle is isosceles. The isosceles triangles have 2 equal sides, which also means they have 2 equal angles. So again, you can see the tick marks. Yeah, Advika, it'll be for the whole week. The single tick marks on these sides indicates that they're equal. The double tick marks just means that, well, since there's no other double tick mark, it just means that that side is all alone. And finally, since these 2 angles are marked the same, that means they're also equal. Also, another word for equal is congruent. And finally, scalene triangles have all 3 sides of different lengths, so which also means all of the angles are different measures. And we can know that because these tick marks, there's a different number of tick marks on each side, which means that none of them are equal to each other.
All right, we went to it fairly quickly, so let us know if you have any questions, just because there's a lot of more important topics in this presentation. So yeah, all of the angles in the triangle always add up to 180 degrees. It's critical that you know this because, yeah, like you can tell by Amy's Zoom marking that it is very important. Okay, yeah, thanks.
Yeah, Rashad, you can do this too.
Okay, so this is the anatomy of the right triangle. Anatomy just means parts. So there's 2 legs, and the legs are usually going to be the sides that make the right angle. And then the hypotenuse is going to be the longest side in the right triangle. It's going to be opposite of the right angle always. Okay. And then the altitude is going to be the perpendicular from the hypotenuse that intersects at the other, like the normal right angle. But it's I think a better way of thinking of it is it's just the height. It's a height, but it's on a different part of the triangle.
Yeah. Basically, it'll always be perpendicular, or in other words, at a right angle to the hypotenuse, but it intersects the vertex of the triangle.
Yeah. So always remember the hypotenuse is the longest one, and it's opposite of the right angle, and then the 2 legs form the right angle.
And of course, you have the right angle symbol.
Yeah.
Which
Right.
is the square.
Next up.
Okay, the next thing I'm going to introduce is how to tell a real triangle from an impossible triangle. So basically, if you just randomly give me like 3 side lengths and tell me to make a triangle with them, there's no guarantee I'll be able to do it because there's some side lengths that cannot make a triangle. So
You can't make a triangle that has side lengths of 1, 1, and 2.
yeah,
Well,
that's not possible.
You take a ruler, you can take a piece of paper, and you try to draw a triangle with side lengths 1, 1, and 2. It's impossible. You can't do it. It like you might not believe me, but it is. You can't do it.
Yeah, and in fact, basically, in order for a shape to be a triangle, the sum of the lengths of any 2 sides has to always be greater than the 3rd side. And why do you guys think that is? Like, just think about that.
I mean, if it wasn't, if it was 2, for it to even be a triangle, like it could just be nothing. Like the lengths could just be 0.
Yeah, true. The lengths do have to be positive. But assuming that the lengths are positive, then there's still some side lengths that won't be able to form a triangle.
Pretty close.
Yeah, visual, that's one thing. It has to be closed.
I don't even know the proof for this.
If think about it like this. You have like a straight line, right? This is going to be one side length. Actually, let me make a line. There we go. We have a line, right? This is going to be one side length of our triangle, but if the 2 sides are too short, like this, they can't connect, right? Because in a triangle they have to like touch each other. But like if they're too short, they won't be able to touch each other and form a triangle. So the side lengths have to be long enough they have to be greater than the 3rd side, because if they're less than the length if the sum of the 2 side lengths are less than the 3rd side, then they won't be long enough to connect. But if they are they can't be equal to the length of the 3rd side either. They have to be greater than the length of the 3rd side. That's because if they're equal to the length of the 3rd side, then what's going to happen is that we have this side, right? But if they're exactly equal to the length of the 3rd side, then the 2 side lengths are going to make actually a straight line with the 3rd side. That's supposed to be a straight line.
Yeah.
They won't
Like,
actually make a
when
triangle.
when you take it and you fold it upwards, it's not gonna touch, even if it's equal, like because it's gonna cover less distance, right?
Yeah. This is the same thing we just explained. I think it's just a good way to think about it. So yeah, basically just to repeat it another time.
Let's see.
In order for a shape to be a triangle, the sum of the lengths of any 2 sides has to be greater than the length of the 3rd side. And you could go, Rashad.
Yeah, any 2 sides. Like, no, you can't pick 2 random sides that satisfy it when two other sides don't, you know?
Yeah.
Like all pairs of 2 sides. 2 sides, not sides.
So this has a special name. This is called the triangle inequality theorem. The name sounds complicated. It's not complicated. It just means the sum of lengths of any 2 sides of a triangle has to always be greater than the 3rd side. If this triangle inequality theorem is not met, then the lengths of the sides won't be able to form a triangle. Okay. So now we're going to do a quick review of the stuff we just went over. So you guys can put your answer in the chat. So what are these sides called?
Wait, it's only 10. Oh wow. Yeah.
Yeah.
Legs.
Good job. They're called legs. Oh, Rashab, you can keep track of points, okay?
Wait 1 second. All right. I got it.
Okay. Yep, they're legs. And what's this side called? Yeah, good job. This is called the hypotenuse, and it's the longest side length in a triangle. What's this symbol mean? Yeah, good job. This is a right angle. Yeah, okay. What do these tick marks mean? Yeah, the tick marks, if two sides have the same tick mark symbol, it just means that they're congruent, they're the same length. Yeah. Okay, and all of the angles in a triangle will add up to how many degrees? Yeah, always will be 180 degrees. And also each angle in an equilateral triangle will measure how many degrees? Yeah, 60 degrees. And finally, an isosceles triangle has how many equal sides? Yeah, 2 equal sides. Okay. Okay, we got the basic stuff down. Now we're going to do some stuff with the triangle inequality theorem. So, can a triangle exist that has that which has side lengths of 4, 9, and 12?
No. Wait.
Yes.
Oh, yes. I did my math wrong.
That's all right. Yeah, a triangle would be able to exist with side lengths of 4, 9, and 12. And the reason is because the lengths of every 2 sides is greater than the third side. So 4 plus 9 is greater than 12. 9 plus 12 is greater than 4. And 4 plus 12 is greater than 9. So yes, this is a good triangle.
There's no batch. It's a triangle. It's not a good triangle.
I mean, yeah, it's going to be a triangle. It's just okay. Can a
There's no
triangle
good
have
triangle
side
that's
lengths
a
of
bad
3,
triangle.
1, and 5? Yeah, this will be a no. The reason is because if we just check, even though 1 plus 5 is greater than 3, and 3 plus 5 is greater than 1, however, 3 plus 1 is actually not greater than 5. So this triangle is not a triangle. It's just not a triangle.
It's not.
Yeah. Okay, can a triangle have side lengths of 100, 100, and 1?
Be a very weird triangle, but yeah.
Yeah, it would be kind of weird. It'd be a really, really skinny triangle. But yes, this would be a triangle. The reason is because 100 plus 100 is greater than 1. Also, 100 plus 1 is greater than 100. And 100 plus 1 is greater than 100. So it would be a weird triangle, but it would be a triangle. So yes, this is a triangle. Okay, now let's do a little bit harder. A triangle has 2 sides of length 8 and 9. What is the biggest possible integer side length this triangle can have? Oh, Tanisha, do you have a question?
Wouldn't it just be infinity if it's
No.
the biggest possible integer?
Think about the triangle inequality theorem. In order for it to be a triangle, what must it meet?
Its sides to add up to be greater. Oh, I got it.
Yeah.
This is so close.
Okay, so for this question, at first it does sound like it would be infinity. After all, it can be basically any side length. However, in order for it to actually be a triangle, it won't be able to have an infinite number of side lengths, because if you have a really big number, remember that any 2 sides have to be greater than the third side. So this means that the side lengths of 8 plus 9 must be greater than the third side length. So what's the biggest possible number, that integer that is less than 8 plus 9? And I see a lot of you put 16, which is I think that's correct, because that would still satisfy the other side's inequalities, because 8 plus 16 is greater than 9, and 9
Wait, we
plus
have a
16
question.
is
We have a
greater than 8. Yeah, okay. Who has a question? Oh, Tanisha.
So for the second one, I still don't understand how you got a no.
Okay, for this one, it would be a no because the side lengths 3 and 1 add up to 4, right? But 4 is less than 5.
Oh, okay.
And since they're less than 5,
It
they
does
won't be able to
satisfy
form a
the
triangle.
theorem.
Yeah.
All right, next slide, I think, right?
I think there may be one more question. Okay, what is the smallest possible integer side length that this previous triangle can have? Yes, said Vika. I think there is a Kahoot today. Okay, so for this question, we basically, instead of considering that, basically for this one, we have to find, okay, I'm gonna represent the side length of the third side by x. So remembering our inequality, we can write 8 plus x is greater than 9 because, again, any two sides have to be greater than the third side. And we can also write 9 plus x is greater than 8, and we could also write 8 plus 9 is greater than x. I mean, you can solve each of these inequalities, but this one we already know is true because 9 is already greater than 8. And this one, I would actually help us give the greatest side length. So really, we should just be looking at this one. So 8 plus x is greater than 9. So if we solve this inequality by subtracting 8 from both sides, we get x is greater than 1. So the smallest integer that is greater than 1 is 2. If you want to, we can solve the other ones, but the other ones would just tell us that x has to be less than 17, which 2 already is, and 9 plus x is greater than 8, which it already is. So the answer would be 2. So yeah, good job. If it's slow for you, can you see the question if it's going slow?
I mean, I can see it.
Okay.
Alright. Special right
For
triangle. I
me,
think this is
I can only see like your annotations like 2 minutes after you write them. So
Oh, there's probably some lag.
and
Okay.
then
it should be
and then,
fine.
like,
It should now it should be fine.
yeah, because
Because
like
they usually
when
doesn't
you
talk
ask
the entire
the
time.
questions, when you ask the questions, it's like 2 minutes later, then my answer in the chat comes.
Oh, okay.
All right, so this is like very, very, very important. So there are two types of special right triangle. Well, there's
There are
four,
more. It's
but
just
these are
the two we're gonna focus on.
and these are really the only ones you need to know to do well. Like the other ones are like kind of irrelevant. There's like 15, 75, 90, but still. Yeah, so there's 45, 45, 90, and there's also 30, 60, 90. So these are both the right triangles. And so this is actually what we're gonna isocles. Okay, or this is what we're gonna use to prove the formula for the equilateral triangle area, which was side squared radical 3 divided by 4. So can anybody tell me some properties of these two triangles? Like, does anybody have any idea?
Yep. Isosceles, scaling, two same sides, right angle, same angles.
Okay, so actually the properties are pretty interesting. And so in a 45, 45, 90 right triangle, the ratio, so of course the legs aren't congruent, but the side lengths have a special ratio. And so the two lengths of the legs are always going to be x radical 2, or in the form of x radical 2. And then the hypotenuse is always going to be, the hypotenuse is going to be in the form x radical 2, and when the two legs are x. So the hypotenuse is always going to be each leg multiplied by radical 2.
Yeah.
Like always.
So for example, if the length of the legs is 1, and that means this one would also be 1, then that means the length of the hypotenuse would be the square root of 2. Or if we say the length of the legs is square root of 2, then that means the length of the hypotenuse would be the square root of 2 squared, which would just be 2.
Yeah. And I mean, like, we can show this in a square.
Oh yeah, we
Like-
can also draw a square.
Yeah. So if you draw a square, so a square is technically a rhombus, right? Because it's a rhombus. So if you guys remember, the area for a rhombus is diagonal 1 times diagonal 2 divided by 2, right? So in this, we can do, if the side lengths of the square are 1, then of course side squared is equal to 1, so the area of the square is 1. But we can also use the rhombus formula. We can do square root of 2 times square root of 2, which is going to be both of the diagonals, and then that's going to be 2 divided by 2, which is also 1. So that's just kind of showing, if you're skeptical, if you're that type of person that thinks that there's a possibility that this is wrong, and you're trying to hastily find a triangle to tell us that it's wrong, it's not wrong.
Yeah.
Every isosceles right triangle. And this is the only isosceles right triangle that there is.
Yeah.
Because you can't really have any other isosceles right triangles.
Yeah, remember this property because it's going to be really, really useful. Okay.
Yeah. So in a 30, 60, 90 right triangle, this one's a little bit harder to remember. So these also have a special ratio. So the side opposite of the 30 degrees, let's suppose that's x. Then the side opposite of the 60 degrees is going to be x squared root 3, and the hypotenuse is always going to be 2x. Okay. I want everybody to write that down just because you're gonna forget.
Yeah, I know. The way I sort of remember is I do 1, 2 square root of 3.
Yeah.
So instead of like 1, 2, 3, you're like 1, 2 square root of 3. Except you have to remember that the side that's x, so just 1, is opposite of the 30. But the side that's twice that is opposite of the 90. And then
a
the
lot of
square root
times
of 3
people
is it.
confuse which of the legs are x and which is x radical 3. I would remember it like this. So like logically, x square root 3 is longer than x, right? So when you think about it logically, x has to be opposite of 30 degrees because it's shorter, and x radical 3 has to be opposite of 60 degrees because it's longer, right? So 60 degrees is going to form a longer, and then 30 degrees is going to form the shorter, right? So the shorter one's going to be opposite of 30, the longer one's going to be opposite of 60, and the hypotenuse is 2x because it's the longest one. Because square root 3 is like, 1.7. So does everybody understand? Does anyone have any questions about this?
No, also, wait, so could you just think of it kind of like the smallest one is x, like the smallest side is x, and then the second largest is 3 squared because like square root of 3 times x, and then largest one is 2x.
Yeah.
Yeah, but you want to remember, like the longest one is opposite of 60 degrees, and the shortest one is opposite of 30 degrees. You don't want to get that mixed up.
Yeah.
All right.
Isn't the longest one opposite of 90 degrees?
Yeah.
Well, yeah, but I'm talking about between the two legs.
Oh,
The
okay.
hypotenuse is always going to be the longest one. So you usually won't get that mixed up. But between the legs, you want to know the longer one is opposite of 60 and the shorter one's opposite of 30. That's about it. But yeah, the hypotenuse is always the longest one.
Yeah, okay. We can do a question. So diagonal of a square divides it into two congruent triangles. Yeah, we kind of,
It's like 2 sides ago.
yeah. If the side length of the square is 2, what's the length of the diagonal?
Yeah. Simplify that. Like simplify it in simplest article form. Yeah,
Yeah,
that's
2
right.
squared 2. Bloop.
Yeah.
How
Okay.
would you? Oh, okay, I got it now. Would that be simplified though? Like, how is that simplified? Isn't it just more numbers?
The definition of like simplified for radical is that you don't want any perfect square factors in it. And so
Yeah.
notice that 8 is made up of 4, which is a perfect square, times 2. So we need to actually move the 4
It's always
outside of
gonna
the
ask in
radical.
simplest radical form. And simplest radical form is always like if you have like square root 32, that's not simplest radical form. You're always gonna have to write what's that 4 square root 2 instead of square root 32.
Yeah.
That's just how it works.
Wouldn't 4 also be square root though?
No, 4 times square root 2.
Okay.
Okay, let's move on to another one. Green equilateral triangle. It has side lengths of 4. What's the length of side AD? And as a hint, find the 30, 60, 90 triangles and then use that to find the
Then this is actually how the
area.
equilateral triangle formula for the area was proved. It was using this formula. And if you want the proof for these formulas, like the 30, 60, 90 one, you have to use trigonometry.
Yeah.
So,
Or you could just use Pythag.
yeah,
Well,
you
it
can
depends.
use Pythag. But in Pythag, like
Well, yeah, that's true. You already need
the
to know
most
the
you can
sides.
do is go through like a bunch of cases,
Yeah.
and test it. But you have to use trigonometry to
Yeah.
prove it. And we're not gonna prove it using trigonometry because
Trigonometry.
most of you guys don't know trigonometry. And also, I don't like trigonometry. That might just be me.
I don't like it either. I would prefer some more elegant solution, but yeah. Okay, so for this one, this angle up here is the 30-degree angle, right? And this angle down here is the 90-degree angle. So this side is the side that is 2x, and the x side is on this side. So this side, oh, sorry, the hypotenuse is twice the length of this side. So the side length DB has a side length of 2. Next, the 60-degree side length is the side that is the square root of 3 times x. So this would be 2 times the square root of 3, which is just the answer.
Yeah. You're gonna see a lot of these in like when you, so I know this sounds kind of like, weird and not really like a formula or anything, but when you solve these competition problems, there are certain angles, like when you draw your random lines, there are certain angles and certain points that you want to draw random lines in because those will benefit you. So you want to draw lines that intersect and make 60-degree angles, or lines that intersect and make 30 degrees angles, or lines that intersect and make right angles or 45-degree angles when you're doing geometry questions, because those are good angles because you can do a lot with them. You can use like these ratios with them. You can make triangles, like equilateral triangles with them, and those can help you a lot. Like you don't
Okay.
want to draw a line that makes a 63-degree angle,
Yeah, that'd be weird.
It's not
Also,
gonna-
someone asked me to explain it again, so I'll just go over it one more time. So remember that in a 30, 60, 90 triangle, the side opposite the 90-degree angle is 2x, or twice the length of the side that's opposite the 30-degree angle. So this means that since AB is twice the length of DB, that means DB has a length of 2. Also, the side that's opposite the 60-degree angle is the square root of 3 times the side length that is opposite the 30-degree angle. So the side length AD would be 2 times the square root of 3. And yeah, that's the height.
Yeah. Okay, next question. Or whatever. Next
Yeah.
slide.
All right. Now we're going to do some stuff on the Jamboard. So let me copy the link.
And after this, we'll probably take a break because it's 10:21. So
Yeah.
good timing.
Okay.
We have very good timing.
We're currently on slide number 4, where it says, what's the length of this triangle's hypotenuse? Yeah.
Slide
Oh, I
number-
preferred for you guys to place it on the Jamboard. So yeah.
Ooh, these tricky problems were pretty good. Like the ones after.
Yeah. I made all of them up. You can sort of tell because it has the background of the slides color.
I get all my problems from random online resources.
Yeah.
I'm not giving points out for this Jamboard just because,
It's hard to
That's
see who
a lot of-
put what.
and that's a lot of you know, going back and forth. Did anybody do math counts last year? Like, wasn't there this weird system? I don't know how it was, but
I think my brother did it. Apparently they did like all their tests on AOPS or something. And
Yeah, I
like
know
the
what
tests weren't
I
even full size. Like they started small and then kept increasing in length over
Oh
time.
yeah, it was
did
weird.
you do it?
And there's like they restricted, like you weren't allowed if you were in 6th grade, you weren't allowed to take the test unless there were open seats for 8th and 7th graders.
Oh, that's kind of sad.
Yeah.
I would base it off of how good you are.
Yeah.
'Cause that's how it was. Well, imagine if Mr. Crampton actually coached. Like imagine. Like he does like what's that one Vishwa, it's a 30 60 90 triangle. What's that one? God, what's his name? It's the school in Lexington. Winburn. Remember Winburn? Their math counts coach actually like coached, you know? Like actually did like taught stuff. So that's why they were pretty good.
Yeah.
But
If
Mr.
Mr. Crampton actually coached, we would be like
He would
crushing
give us-
everyone.
he would just like get an Oplet account and then just
Yeah.
like random questions off.
Can I explain how I got 4? Because I don't know if I'm right or not.
Sure, you can explain.
What I did is I found, since the hypotenuse is going to be 2x, which means that the left leg, like near the third angle, would be 4.
And oh,
So that means I'm probably wrong. But then what I did is then I got 4 square root of 3 on the bottom.
okay.
And then I kind of just thought if x is 4 for this, then x would also have to be 4 for that. But that's not a,
It's 2 square root 3, right? Or wait, no.
that's not 30, 60, 90. Oh, I
Oh,
think
where is the 30, 60, 90? Which one's not? All of the triangles
the
in that
one-
image.
it's
All
one
right.
where it's x, like the triangle that's made up of x as its left side, kind of.
Yeah. Is it this one?
Yeah, that one.
That one actually would be 30, 60, 90. The reason is because this is a 30-degree angle. This angle belongs to both the big triangle and it's also part of the smaller triangle. And because the smaller triangle is an altitude here, the side length is an altitude. So it intersects the hypotenuse at a right angle, which means that this angle is actually 60 degrees.
Oh, okay. So then,
So you're almost there. It's just you need to use the properties one more time.
okay. I mean, I kind of guessed it before because, but I don't know. The formula for like it's 3 square root x, right?
Yeah, for the 60
Or square
degrees.
root 3x.
Yeah,
times
for
x.
the 60 degrees side.
Then yeah, I don't know.
Okay. I'm gonna give you guys a hint. So on you're almost there. You got the side length of the big triangle. And now you just need to find the side length of the smaller triangle here. So this smaller triangle is another 30, 60, 90 triangle. But notice that this side, which you got the 4 square root of 3 for, that is actually the hypotenuse of the little triangle here. And the side length x, which we're looking for, is opposite the 30-degree angle.
Okay. Wait, what?
Wait, Amy, is
Yeah.
your brother in 6th grade?
Yeah, he's going into 7th now,
No, at Mizik or what?
Busy. You know what's so funny?
What?
The funniest thing is when everyone's like, when they're writing on the Jamboard, but instead of using the square root sign, use the SQRT abbreviation.
No, actually, some people. Oh no, man, that's. Yeah.
I mean, there's nothing wrong with using the abbreviation. I think it's kind of funny though.
I remember
Oh
we gave
yeah.
this math counts question and he couldn't solve it, and we were like, it's very awkward.
Okay. I'm gonna go over the okay. I think I'm just gonna go over
But make sure
For-
nobody cross the point that they're not supposed to go past.
Okay. For slide 4, it says what's the length of this triangle's hypotenuse. I think you guys pretty much got the gist. The hypotenuse is twice the length of the side that's opposite the 30-degree angle. So twice of 4 is 8. And then for number 5, for this one, you just solve for the length of the 30-degree side first, and then use that to find x. So the 30-degree side would be 1/2 the length of the hypotenuse. So that would be, the length of this side would be 4. And then the side x would be the square root of 3 times 4. So 4 square root of 3. And then finally, this question is a little bit tricky. The reason is because there is actually multiple right triangles in this image, and we need to use basically almost all of them to solve. So I'm just going to explain from the beginning, just so everyone can get it. So first we have first we need to solve. We can just basically solve for as much as information as we need, and then use that to solve for x. So first, the side opposite the 30-degree angle would be have a length of 4 because it's 1/2 the length of the hypotenuse. And then the side opposite of the 60-degree angle, which is not marked, would be 4 square root of 3. So now we just have to review what we're looking for. We're solving for the side that's labeled x. So we need to, we can just focus on this triangle here and just solve for x using that. And the reason we can just
Smaller one
Or
because
you
the
can-
4 is the hypotenuse, and then just take half. Then half of that's 2, and then 2 square root 3.
yeah,
You
it
can
works
use
either way.
either of them, or you can
Either
do
way.
4 square root 3 divided by 2 to get 2 square root 3.
Yeah, either way is fine. You can use this smaller triangle here, up here, or you can use the medium triangle down here. In fact, I'll just demonstrate both of them just to show that they're the same. So if we first use this medium triangle down here, basically this is a 30, 60, 90 triangle actually. So the side length that's 4 square root of 3 is the hypotenuse of this medium triangle. And since the side length labeled x is across from the 30-degree angle, that means x is 1/2 of 4 square root of 3. So x equals 2 square root of 3. That's using this medium triangle. If we decide to use the smaller triangle up here, it's the same thing because this is also a 30, 60, 90 triangle. If you need proof, just note that this angle up here is 60 degrees. And since this is a right angle, that means the thing down here is 30 degrees. So since this triangle up here is a 30, 60, 90 triangle, we can use the same property. Since the hypotenuse has a length of 4, that means the side opposite the 30-degree angle, which is up here, would have a side length of 2. And since that side length has a length of 2, that means the side length labeled x would be square root of 3 times that. So again, x equals 2 square root of 3. You get the same answer either way.
All right. I think we're done halfway, right?
Yeah.
Okay, so
Oh, whoa.
no,
Wait.
it's 10:32, so I think we should
Yeah.
just take a break now.
Let's find it there. Okay. You guys can have a break.
Wait, if we found that was 2 and then the hypotenuse of the medium triangle would be 6, right?
Um.
How did you get 6?
8
Oh. This isn't the
Oh, wait,
hypotenuse.
yeah, never mind. Okay.
Yeah, but it would be 6. Yeah. Okay. Breaks over. Okay, let me just go back to where we were. Okay, so okay, our next topic is the Pythagorean theorem, which I mean, do you guys already know what it is? Yeah.
It's a squared plus b squared equals c squared, right?
Yeah. Okay. Yeah. Yeah, that's basically what. Okay, if you don't know, that's okay, and if you already know, that's also okay. Hopefully, you can still learn. So, I like these images. They basically so this first image. What's something you notice about it? Yeah, it's 3, 4, 5. Yeah. Yep, there's a lot of squares. Also, they're perfect squares. They're squares with an area of the side squared, and they happen to perfectly the sum of these two perfectly equal the square of the fifth side, which of course is just the Pythagorean theorem, if you don't already know. This one I also like. It shows how they perfectly, the squares of the legs perfectly equal the fifth square of the fifth side. It's a nice visual representation. I actually like this one a lot. I kind of like, this is the type of thing that I think would be really cool to build. Yeah. So basically, the Pythagorean theorem tells us a relationship between the side lengths of a right triangle. So this is a right triangle. So it tells us that the square of square of one leg plus the square of the other leg equals the square of the hypotenuse. And this is really useful because that means that if you're given a problem where you don't know the side length of one of the legs, then you can solve for it. It also means that you can use it to tell if a triangle is or isn't a right triangle. Because if it is a right triangle, it should satisfy this. But if it's not a right triangle, it should not satisfy this. So, yeah. So, as an example, let's check if this triangle is a right triangle. So, we have to basically ask, if we plug these numbers into the Pythagorean theorem, does it work? So Pythagorean theorem tells us a squared plus b squared equals c squared. So that means 3 squared plus 4 squared should equal 5 squared if it's a right triangle. So does it equal 5? Is this equation true? 9 plus 16 equals 25. 25 equals 25. Yes, this equation is true, and this tells us is that yes, this is a right triangle. Rashad, you could do this next one.
Okay, right. Okay, so yeah, so essentially for every right triangle, you should check whether a squared plus b squared equals c squared. So check for this triangle if it is a right triangle. All right, so we have a couple of answers in the chat. So just use the Pythagorean theorem. Okay, so everyone's saying no, and that's correct because the Pythagorean theorem, so 3 squared plus 5 squared is 9 plus 25, and that does not equal 64. So it doesn't satisfy the Pythagorean theorem. So that means it's also not a triangle because 3 plus 5 is
Yeah, not only is it not a right triangle, it's not even a triangle at all. So,
yeah.
Yeah.
I'm looking at it. I'm like, it's not a triangle.
Yeah. Yeah, so I mean, Pythagorean theorem is really useful for checking if it's a right triangle, assuming that it is a triangle, which this one isn't. So it's obviously not
A
a right
lot of
triangle.
times you can also assume it's a right triangle because I mean, like again, math counts and all these other competitions are usually to scale. Also, it's handy to memorize some common Pythagorean triples.
Oh
Three,
yeah,
four,
we're gonna go
five.
over that in a little bit.
Oh, okay, all right.
Yeah. Okay, let's do another problem. For this triangle, it's a 5, 7, 8 triangle. Is this the right triangle? Yeah, this one would not be a right triangle because again, we use the Pythagorean theorem, a squared plus b squared plus c squared, plug in some numbers, 5 squared plus 7 squared. Does that equal 8 squared? It does not. So yeah, off by 10, off by 10. It's a little bit tricky. So yeah, it's not a right triangle. So I hope you guys get the gist of that because now we can also use the Pythagorean theorem to solve for side lengths. Rashad, you could do this slide.
Yeah, so this is actually a very common Pythagorean triple. One I highly recommend memorizing, even though memorizing is not very, very good. So find the value for C in this example. Or we already have two answers. So yeah, it's 13. So this is a very common triple. It's 5, 12, 13. So yeah, 5 squared plus 12 squared equals C squared. So 169 equals C squared, and the square root of 169 is 13.
Yep. Of course, this only works if we already know it's a right triangle. If it's not already a right triangle, then it's
Okay,
we
so like
don't-
example, these are actually very good examples.
Yeah.
Because I mean, like anybody, any one of the teachers can like look at these examples and probably tell you the
answer without even
answer without
actually-
even thinking about the Pythagorean theorem.
Yeah,
Just
because
these
we
are
memorize it.
Yeah, these are very common triples. Like
Yeah.
what? 3, 4, 5, 5, 12, 13, 8, 5, 17.
9, 40, 41.
Yeah, 9, 40, 41. 6, 8, 10, even though that's just 3, 4, 5 times 2.
Yeah. Yeah, basically, yeah, for this one, a squared plus b squared equals c squared. So this would be a squared plus 15 squared equals 17 squared. You solve the equation. So the a is the square root of 64, which is 8. So good job, everyone. And yeah, like Rashad was saying, there's things called Pythagorean triples,
Oh,
which are
also
basically
7, 24, 25.
Oh yeah, 7, 24, 25. There's things called Pythagorean triples, and the reason they're called Pythagorean triples is because not every combination of side lengths can be a right triangle, and the same combination of side lengths comes up a lot. So I think Rashad is listing some in the chat, so I'm gonna join it. Yeah, there's a lot of
Yeah, I already said that.
Yeah,
Well,
so if you want to, you can memorize those triples as the side lengths of
I
a
would
right
recommend
triangle.
3, 4, 5, 5, 12, 20, 5, 12, 13, and the 4 ones that I put are probably, I would say, the most important ones, like the first 4, and then also 9, 40, 41. And see, yeah, so like as Harsh is saying, you see 3, 4, 5, 6, 8, 10. When you multiply 3, 4, 5 by 2 or 3 or 4, then all of those are Pythagorean triples as well.
Yeah.
It's just 3, 4, 5 is like the primitive one.
Oops, that's the break. We already went through a break. We don't need another one. Okay. Oh, back to the Jamboard. Okay.
Yeah. Go back to
Okay.
the Jamboard.
Yeah. We're
Just solve the questions after the do not go past one side.
yeah.
Starting slide number 2.
Don't do all. Actually, you can do them. You can basically just do them because yeah, just do them. And we after a point we'll just probably go over them. Some of them. I don't know if we can go over everything though.
We'll go over the fun ones.
Yeah, we'll go over the fun ones.
The ones we want to solve.
I feel like you guys have already been working on them. It's just that since it says do not move on, you just didn't put your answers down, so we wouldn't know.
This was not that hard.
Yeah.
Well, I mean, I don't think our opinions are very valid.
Yeah, that's true.
Wait, Amy, you made Amy this year, right?
Yeah.
That was a weird sentence to say.
Yeah, because
Amy sounds like Amy.
yeah. That's why I never say it really fast.
Yeah,
I
you
just
should
say
say
each
AIME.
letter AIME.
What does it stand for?
American
American-
Invitational Mathematics Examination.
Oh, and then JMO is like Junior Mathematical Olympiad.
Yeah.
Apparently, Luke made JMO last year.
Oh shoot, this is not. Oh, really?
Yeah, last year.
Wait, but then what happened this year? Did he
He
make it?
didn't make it.
Oh. Oh, okay.
Apparently, he was very lucky.
Hmm. Yeah.
No doubt. Yeah, he skipped 2 grades. He skipped 1st grade and he skipped 3rd grade. He has a brother, yes. No. His brother's in college. Oh, Amy, Jonah and Justin got first at Nats.
Yeah, I know.
That I saw that. I was like,
Crazy. It's like the very first event. We were like, okay, just waiting for it. And then it's like first place, first event. It's also
well, and the
the
thing is, it's not like any like random, like, irrelevant event. It's anatomy.
yeah, which is very competitive.
Yeah, I would say it's the most competitive. Like, just at Manual alone, like 20, 30 people tried out.
Yeah. I mean, I think it helps that they're brothers because
Yeah.
then they can study together.
I think it gave
over
them a
some-
little advantage, especially like taking the test too. Because everybody did it like remotely, right?
Yeah. Oh, you're right. Oh,
You
they
know?
could just take it in the same room and talk.
Yeah.
Actually,
they
like
have
talk.
that advantage.
Yeah, that's true. Yeah. He did.
But he goes to Northwestern now. Yeah, that's true. Yeah. He skipped senior year and just went straight to MIT.
That's crazy.
It is.
I didn't know
He also
that.
got top 5 in the country in chemistry Olympiad.
Oh wow.
Yeah, he went to MIT in Olympiad.
But what was the like thing that added up to 169? Like
13.
something and then 13 was the hypotenuse.
5, 12,
5
13.
squared and 12 squared.
Okay, thank you.
Yeah, 5, 12, and 13. Do you know where Justin's going to college? I'm curious.
I don't know. Wait, what slide are you guys on so far? In the
Imagine
January?
somebody's just like done.
No.
If you're already done, I'm gonna just make you the winner.
There's no one done. Also, if you do get to the end, I'm gonna be kind of impressed. But if you don't, that's fine. And don't feel obligated to try to get everything done. Like if you make it to slide 13, I'm pretty impressed.
Of course, that's not your limit.
Oh yeah, you can still go to the end. Okay. I think someone would like help on slide 10. So I'll just go over slide 10. Or actually, I can give you guys a hint if you want, instead of just giving
This
you the
question
answer.
isn't fun though.
Well, someone asked for me to go over it. So
Okay.
basically, for this question, it says the triangle is removed from a rectangle forming a pentagonal shape. What's the area of the pentagonal shape? So for this one, what you do is you first find the area of the rectangle, right? And then you subtract the area of the triangle here. So that means you need to find the area. To find the area of the triangle, you need to know the side lengths. And in order to find the side lengths, you have to do, well, first of all, notice that it tells you that this part has a side length of 7. And the main side has a side length of 12. Therefore, we do 12 times 7 to find the side length of this side of the triangle, which is just 5. So then to find the side length of this part, we notice that this long side length has a length of 25, and this part of the side has a length of 13. So that means that this part would just be 25 minus 13, which is 12. So now we essentially have the side length, or of course you could use the Pythagorean theorem, but either way, now you basically have the side lengths of the triangle. So you can find the area of the triangle and subtract it from the area of the rectangle, which the area of the rectangle is 12 times 25, which I need to quickly
That's
calculate.
like 300.
Oh yeah, it is 300. That's
Right.
300. So then the area of the triangle is 12 times 5 divided by 2. So that'd be 30. So 300 minus 30 equals 270.
Yay.
I
Okay,
see
next
a
question.
request for questions 11 and 12. So
11 and 12, I got you. Okay.
Yeah.
All right, so 2 red triangles in the diagram are congruent and intersect the midpoints of each other's sides at the blue points, forming a small square in their intersection. The green side has a length square root 2. What is the length of one of these? This question is like annoying but good at the same time. Okay, so this is square root 2. I'm not gonna write in red. That's not a good idea. I'm gonna
Put it
write
in
it.
blue,
I'm gonna do it in like this one, this color. So
yellow.
this is square root 2.
Oh.
Right? So this is a square, right? So we know that this is 1, right? Because square root 2 times square root 2. Oh, sorry, it's not. Oh God,
Control Z.
what?
You could just Control Z.
It's fine. It's 2, right?
Yeah.
And then this is also, so this is 2, right? And it says, what's it asking for? What's the side length of one of the larger squares? And then these
How
are
do
the
you know it's
midpoints.
2?
So yeah, so since this is 2 and this is the midpoint, this is also 2, and so 2 plus 2 equals what? 5, right? So the answer is
I'm confused how you got 2.
what?
I'm confused how you got 2.
It's a 45, 45, 90 triangle. So we just do square root 2 times square root 2.
Yeah, this little
Triangle.
middle triangle here is a 45, 45, 90.
Okay.
Yeah,
Yeah.
and then we just did 2 plus 2 to get 5. That's about it.
You mean 4?
No, it's 5.
Oh, okay.
Yeah.
That's interesting.
All right, number 12, right? Number 12.
Yeah.
I'll let you do number 12.
Okay. I like this one. I worked hard on this question. John made a flag designed for. Oh, no, I mean, I didn't work hard on the flag. I worked
Amy's
on the-
very good at writing questions.
The flag is made up of right triangles ABC and ADB. Side AC has a length 13 and side BC has length 12. If side BC is 3 times as long as side BD, what's the area of quadrilateral ADBC? Okay, this is kind of a mouthful, so we can just sort of split the question up because, yeah, why not? Okay, I like this part where it says side BC is 3 times as long as side BD. Side BC has length 12, okay? So if it's 3 times as long as side BD, what's the length of side BD?
It's 12 divided by 3, which equals 7.
It equals 4. So side BD equals 4. So,
I'm not very good at math.
okay, so now we need to find the length of side AB. So for this, we can just use the Pythagorean theorem. So 13, it'd be x, we can just call this side x because why not? X squared plus 12 squared equals 13 squared. And that would mean x equals 5. Or if you have it memorized, you could just jump straight to the end. So side AB has a length of 5. So yeah, and now we just need to find the length of side AD. That would be 3 because you can use the Pythagorean theorem, or you can remember it's a 3, 4, 5 triangle. It's a right triangle. So we have all the side lengths. So now in order to find the area of this quadrilateral, which I'm about to shade in over here, in order to find the area of this quadrilateral, we have to find the area of the big triangle ABC and subtract the area of ADB. So that would be 5 times, oh gosh, that's not the right 10. Hold on. Okay, you do 5 times 12 divided by 2. That's the area of ABC. Subtract 3 times 4 over 2 because that's the area of ADB. So that's 30 minus 6, which is 24. Yay. Oh, there's
Oh, I didn't know what it meant by quadrilateral ADBC.
Oh, okay.
Yeah.
I mean, I don't really know what to say. All right.
I mean, just think about it like this. When it says A, when it gives you a series of letters, trace out the letters on the paper. So for example, this one, it says A, D, B, C. So you might be a little bit confused at what shape it is. So first find point A, right? And then you find point D, and then B, and then C. And then you just trace it. So you go from A to D, D to B, B to C, and C back to A. So then that traces out the shape that we're solving for.
Or we have some requests for number 9, and
Yes.
there's some conflicting answers and question marks. So I think we
I
should
don't know
go-
what's going on in the chat because
How did you get
what?
2 plus 2 equals 5? Can you
You
explain?
just have to use trigonometry.
I think it's a joke, guys.
Okay,
Yeah.
that's right.
I was playing around. Okay.
Yeah.
So a square ABCD has side length 4. Equilateral triangle BCF has side length that coincides with side.
The side of the square.
Yeah, find the length of segment EF. All right. Okay. Express your answer in simplest article form. Okay, so this is 4. Very nice. This is also 4. Okay, so EF. Where's EF? EF. Okay, yeah. This is EF, right? I can't really see well. So we draw this line right here. This is an equilateral triangle, by the way. So this is a right angle. This is 60 degrees, and this is 30 degrees. I think I should label those. 60.
You need to make the marks different from each other.
Oh God. Okay. I'll just
Add another mark. I'll add another one on 30. There.
you do that. Okay.
I
nice.
added it.
All right. Okay. So this is 4. So actually, I should get rid of this 4 and then replace it with like a 2 and a 2.
Yeah.
That'd be easier. So this is 2, and this is 2, right? So 2, so that means this is 2 radical 3 because it's 30, 60, 90, right? And this is 4, even though we really don't need that, all right? And we're solving for EF, right? So let's like if I draw another height, so if I draw this line, this is 4, right? So we just do 4 minus 2 radical 3, right? Because we're solving for that, like EF, and we know that part of this line, this whole line, part of this line is 2 radical 3, right here, right? And so we just do 4 because that's the total length. We do 4 minus 2 radical 3 to get that this tiny segment right here is 4 minus 2 radical 3, right? Pretty good. Understood. Does everybody get it? All right, nice.
Yay.
Does anybody have any other requests that we should go over, or can we just like do what we want? No other requests? All right, cool.
The hexagon one? Okay, which
Oh
hexagon?
yeah, we
one?
got to do that. We were gonna do it even if you guys didn't want us to. Just look at it. It's
Which
like
one?
vibrant.
Is it number 15, 16, 17, or 18? Because all of them have hexagons. 17.
Those are
Okay.
15. 15 is the boring.
All
We want
right.
to do 17. Do you want to do or should I do it?
You can do it, but I'll like cut in if you go down the wrong way because there's a good way to do this that doesn't require like
Okay, if the
thinking.
combined
Well, it
area,
requires thinking, but it's not like actually.
if the combined area of the green triangle is 96 square root 3, find the area of the blue hexagon. This is a good question. All right.
Okay, wait. Let me just ask you something.
Oh yeah,
Do
I
you think
got it.
this will take multiple steps or just a few steps?
Okay, I got it.
Okay.
So wait, so Amy, let me just confirm. So we have 6 green triangles, right?
Yeah.
So the area of the green plus red equals 192 square root 3, right? Or wait, no. It equals 192 square root 3. Green plus red, I believe.
Green plus red.
With the area of the
Yeah.
would the
Yeah.
height of the red triangle be square root 3 divided by 2?
Hold
Okay,
on. You
so-
guys don't need to find that actually.
Okay, so if I draw this line right here and if I draw this line right here, you can kind of just like, so this, let me use the highlighter. Where's the highlighter?
Use the brush one. The brush one is actually like a highlighter.
Or this, oh God, that's not showing up. This
red.
region, oh, that's not showing up either.
Okay, never mind. Forget what I
This,
said.
can you see this? Can you?
Not really.
There.
Or kind of. Okay, yeah, I can see it.
You can?
Yeah.
Okay, this like whitish region right here, this region right here, there. This region right here is equal to this region,
Oh.
right? What? Yeah, it's equal to this region. When you draw these like lines that go through, they're both 30, 60, 90 triangles. So we have that the area of all the green triangles is 96 radical 3. So since all of the red triangles have the same area as the green triangles, we know that the green plus red equals 192 radical 3, right?
Wait. We're looking for the area of the blue hexagon.
Yeah, I know. So 192 radical 3 equals green plus red, okay? But we're looking for blue. So what I'm gonna do is I'm gonna take blue and I'm gonna split blue right here and right here
Okay.
and right here. Okay, so you can see that this blue equals all of these red ones, and we established before that the green equals the red, and so we have six essentially red triangles right here, right? So that's also just 96 radical 3. We didn't even need the one.
Yeah, I was so confused when you wrote 192.
No, you see, I'm solving it, so like
Yeah.
I think I might need it later, but then I realized that I don't. You know?
Yeah. Just to recap, the area of all the green stuff is the same as the area of all the red stuff, which is the same as all the area of the blue stuff. So
We're splitting this into 3 areas, and they're all
yeah.
the same.
yeah, and just again, one of the tips Rashab gave us was to draw random lines. Like the lines shouldn't actually just be random, but if you like draw lines,
They
you
should be
can
smartly drawn.
see, you can basically sort of tell that, you know, this area is pretty much the same as this area. This area is pretty much the same as this area, which means that the green and red are the same. And then if we draw the lines across the hexagons,
Like
we
another
realize
way
they're
you can think of it is like you see this region right here, this what I'm making white, this right here, right? If we take this and we just like move it right here, then we're gonna get something that looks like this.
if you rotate
Right.
it, and then you can
And this-
basically get another
And
triangle.
they both look the same, right? This and this, they both look the same, right? The red, and if you take that part of the green, you move it over, they both look the same. So they're both equal. So since the green equals the red, and the red equals the blue, which is split up into 6 things, we can just do, it's just the same. It's both 96 equal 3.
Yeah, all of the area of all the colors is the same.
What you could do is you could actually use algebra, solve for the side lengths, do all that stuff, but like nobody wants to do that, right?
Yeah.
We're gonna save time here. Questions
Okay.
like these have a simple way to go around them. Well, usually they do. If they don't, then sucks to suck.
Okay. Does anyone have some other questions to explain that what they wanted us to explain? If not, I think we can just head to the Kahoot because it's 11
Is the
to 10.
formula stuff like, would we be wrong if we wrote something else?
For which one?
Like this, like the hexagon and triangle one.
I mean,
No,
if you
not
get
those hexagons, the go back a little, I think 16.
oops, here.
Yeah. Would we be wrong? No, one back.
Yeah.
Yeah. Would we be wrong if we write something different, like for the triangle one, which is one back two, one back?
Mm-hmm.
Like would that just be wrong or?
Hold on, let me just write it out in a normal way because it's kind of hard to do. Okay, s squared minus s over 4 times s over 2 times 2 times 1/2. Okay, one thing. These will probably cancel. I'm not
You
not
can't
exactly
use
sure
the
that.
Lagrange theorem on equilateral triangles.
What?
You can't use.
You muted yourself in between your
No,
sentences.
I was like thinking in a way that since this equilateral triangle could be like 2 right triangles,
Yeah.
if you find the area of one right triangle and multiply it by 2, wouldn't that give us like the answer?
Yeah, that's how you get the answer. Yeah.
Yeah.
Okay, so it's
Yeah,
that's why I was kind of trying to use the Pythagorean theorem to how to find the other sides, and then
You can use 30, 60, 90.
yeah.
Yeah.
Pythagorean theorem might be a little bit. It might bring you through a lot of different steps to get the
It's
answer.
gonna overcomplicate things.
Yeah. Okay. I think we'll just do a Kahoot now.
I have to go now.
will there be for the Kahoot?
What?
How many points will there be for the Kahoot?
I think just 3, 2. First place gets like 3 points, second place gets 2 points, and third place gets 1
Yeah, I
point.
can stay. I can stay. I think it's fine.
Okay. Someone asked for number 19. Okay, I'm not gonna go over this one because this one's a little bit complicated. It uses a lot more. This is more of an algebra problem, not actually a geometry
Well, we
problem.
can go over it like tomorrow or something.
Yeah.
Or no, Thursday if we have extra time. All right, I think you should display the game pin now.
Yeah.
Or we have one person. That's interesting. 4.
4 people.
5, 6.
Actually, it's been a long time since I actually looked at the Kahoot, so I don't actually know if it's like in a good shape or not. I remember, I know Shani had to tell me to correct a couple of things
You guys
because I
want me to
forgot.
play? Wait, do you guys want me to play? I don't have a piece of paper. So
Sure,
Does
you can
anyone-
play.
I bet. I mean, I'm already in. I'm Joe.
Okay, does
Um,
anyone else want to join? We only got like 7 people. It's 6 people technically.
Well, by the way, if I lose, then don't flame me. I don't have a piece of paper, and I'm not really gonna try that much. So I'm just putting that out there. Because I remember I did a Kahoot last week and I lost. It was very devastating. I got like second. I guessed on like half of them because I didn't feel like trying.
Is anyone else going to join? There's only like 5 people and there's like 20 kids in this class.
The poll will be so easy today.
Okay, I'm
Dude,
going to be
who's
starting.
Bob? Who's Bob? Who's Bob? I'm Joe. I'm just saying.
Okay. First question. Evaluate the square root of 121. Why isn't there any sound?
I don't like sound.
No, for me. Oh, I
Oh.
can hear it.
Well, that's your problem.
I kind of like the sound.
Yeah.
Yay! Everyone got it right.
Let's go.
Oh, wow.
Oh.
Well, I mean, it's only like 9 points off. So, okay, square root of 64 plus square root of 25.
Guys, it's obviously 5. Like, if you don't get that, then you don't actually you
Yay! Okay.
really don't know anything
Who's
if you don't know
making
it's
me really
5.
Oh my gosh. Leaderboard really shifted. Solve for x. Square root of 144 equals x plus 2.
Okay, this one's 12. Like square root of 144 equals 12. It's 12. Very easy.
Okay, yeah, it's 10 because
What's
x plus 2 equals 12, but that means 10 plus 2 equals 12, so x is 10. Okay, longest side in a 30, 60, 90 right triangle is how many times longer than the shortest side?
I misclicked. I didn't even mean to click it, and it just happened.
Oh no.
Well, suck to suck. That sounds like a you problem. Ah, okay.
Okay, 45, 45, 90. Longest side is how many longer than the leg of a triangle, right? Or yeah, triangle. Okay, yeah, it's square root of 2. Because this is a 45, 45, 90 triangle. Joe is in first place. Manny, you need to try to beat Joe. And
No,
we'll
Joe is
same
gonna
goes for
beat-
everyone else.
Joe can't lose.
Find the length of side X in the image.
Where's the image? Oh, shoot, I see the image now. Oh God, I think I lost. I couldn't
Uh-oh.
see the image. Like I know I got the right answer, but I couldn't see the image.
Oh,
Very devastating.
maybe because I moved some stuff around on my screen. Okay, yeah, it would be 8.
Let's go.
Ooh, it's really close. Okay, find the length of side X.
What if we give the win 4 points?
40. Yep. This is a 9, 40, 41 triangle. Okay. Is this a right triangle? Okay, I don't know what these are, but you can probably assume they aren't the right answer.
It's yellow.
I don't know what mood I was in when I made this code.
No. Hold up. This isn't even possible.
Yeah,
That triangle's not even possible.
yeah, you're right. It's not even a triangle, so it's definitely not a right triangle.
I think I lost.
The image tricked me, dang it.
Oh
Oh
god.
my gosh, it's close.
I'm still
Okay,
the best. Though.
is this a right triangle? Yeah, this is a
I'm the goat. I'm the goat.
yay. Yep, this is actually a 3, 4, 5 triangle, except it's like it's a multiple of it's times 2, so it's 3, 4, 5, 6, 7, 8. 6, 7. Oh my gosh. 6, 8, 10.
Show us the podium.
Oh, it's
All right,
here.
that's a blue one.
All right, Joe is in first place, unsurprisingly.
Come on,
Minnie is close behind. Winner AR is making her way up the leaderboard. Vishwas close behind, and Bob is in 5th.
Who's Bob?
Which of these cannot be the angle measures of a triangle?
Amy, I can't see the options.
I hope you can see it now.
No, I thought the blue one said 100 degrees, not 120.
Uh-oh. Okay, I don't know.
I can't see the options. It's fine. I just
Uh,
guessed.
eh.
Oh, which one did you guess, Rashab?
Guessed blue.
Okay. Yeah, it's blue.
I think I lost it because I did it very, very late.
Oh, yeah. Okay, Minnie. You're
Hey,
in
I'm
first.
still the
You
winner,
better
though,
try
I
to hold
guess.
on to that lead. Okay. Which of these could be the angle measures of a triangle? I hope I didn't get this mixed up.
I still can see the options. So should I just guess again?
Sure.
Oh, wait, I can see them now.
Oh man, I should have just told you something.
Oh,
Oh,
Also,
wow.
eight.
Cool.
I did that so late.
Yeah.
Oh god. This isn't good.
Oof.
I'm gonna lose.
Okay. Can a triangle have side lengths of 6, 7, and 8? Yes.
How many questions are left?
I think there's 25 questions, and we are on
more, you're only losing
question
by
12.
9.
So we're halfway through.
All right,
Triangle.
I have time.
Can a triangle have side lengths of 18, 17, and 1?
I didn't misclick, like I flicked over the right answer. Okay, thank God.
Oh, okay. Yeah, this will be no. 17 plus 1 is not greater than 18. Okay.
Oh god.
Joe is once again in the lead.
Oh, I'm winning. Oh, I thought I was losing.
A triangle has side lengths of 5, 4, and 7.
Imagine if all of these were like the Jamboard questions. That would be way easier for me.
Yeah.
Just because it'd be way harder for everyone else.
Okay. Rectangle has side lengths of 7 and 24. What's the length of its diagonal?
Where are the options? Oh, there.
If you're stuck, remember that a rectangle would just be two right triangles with the diagonals at hypotenuse. Okay. Yeah, so you would use the Pythagorean theorem. 7 squared plus 24 squared is 625. Square root that, you get 25.
Let's go. Wait, why am I not on fire?
36 because it doesn't like you, Rashad. No.
Oh, that's
Okay.
so.
30, 60, 90 triangle hypotenuse of length 8. What's the area of this triangle? Yeah, for this one, you need to take a few more steps.
No, I forgot to square it again.
Oh no. Okay,
The first one, guys. Let's go.
okay. This one would be the one
It's
side
4
would
times
have a
4
length of
squared root
4,
3
the
divided by
other
2.
one would be 4 square root of 3 multiply divide by 2. Originally, I had the answer as 16 square root of 3 because, of course, when I made the Kahoot, I forgot to divide by 2. Okay, 30, 60, 90. Hypotenuse of 8. What's the perimeter? Okay, I hope I didn't get this wrong. Okay. Yeah, this one would be 12 plus 4 square root of 3.
I think I lost. Oh, I'm still winning.
I fall behind like
45, 45, 90 triangle hypotenuse square root of, or 2 square root of 2. Find the area.
Oh, this is so laggy. It's kind of sad.
I just guessed on this one. I had no idea.
Yeah, but this one, you would need to find the length of the leg. So since the hypotenuse is the square is the length of the leg times square root of 2, that means the leg would have a length of 2. So 2 times 2, and then you have to multiply by 1/2 because it's the area of the triangle. That'd be just 2. Okay, area of an equilateral triangle with a side length of 4. Yay. Almost all y'all got it right. So yeah, this would be 4 times 4 because s squared, and then you'd multiply by square root of 3 over 4, so 4 square root. Dang. Second, third, and fourth are so close.
But
Okay.
none of them can beat me.
Find the perimeter of an equilateral triangle with an area of 9 square root.
So I'm answer 1.
Ooh, wow.
I'm done.
Okay. Okay.
All right, so it has an area of 9 square root 3. So side squared radical 3 divided by 4 equals 9 square root 3. So you multiply both sides by 4, you get 36 equals side squared radical 3. So that means side squared must equal 36. So side equals 6, and then 6 times 3 equals 18. That's about it.
Oh,
Oh no, I think Manit got it wrong. I'm sorry,
Well,
man.
length of the shortest diagonal in a hexagon. The hexagon has side lengths of 8.
Oh, this is a good one.
Yeah,
Oh, but I got
I
it wrong.
like it.
Nice.
Did you actually?
No, because the answers aren't loading. So I just kind of I was like clicking it
Oh,
for like I was like, kind of like, come on, the answers must load. But then when it loaded, I was still clicking, and I clicked on like 16 or something.
imagine if it's right.
It's not right. Oh, I probably shouldn't say that. The answer is 4. It's 8 radical 3.
Yeah, it would be 8 radical.
Am I still on the podium? If I'm still in first place, because I
I
got
would
it.
assume you are because you have a bit of a lead.
If I'm still in first place, I'm actually gonna be ecstatic. Oh, let's go. I'm still up at like 2,000.
If Rashab gets a couple more questions wrong, you guys still have a chance.
What
With
if
the
I like
following side length
don't
three sides of the right
do the
triangle.
rest? Okay, yeah, this one's yellow, no doubt.
It's not yellow.
It's not even a triangle.
Yellow is not even a triangle.
14, 30, 34, 7, 15, 17. 5, 12, 13. You misclicked on that one? No, it sucks to suck. That's a you
Oh.
problem.
Yeah, this one would be the answer because it's 5, 12, 13. So that is, if you know your Pythagorean triples, then yeah, it's that. If you don't, you can just
you
divide by
don't,
2 and then try the Pythagorean theorem and see if it works.
Yeah.
Oh, many to climb and back up. Okay, how many Pythagorean triple? Oh no, we didn't go over this. It's infinity. I just told you guys the answer. Okay.
It is? I
think,
thought
yeah.
it was 900.
No.
You can keep multiplying the 3, 4, 5 as in Q1.
Yeah, exactly.
Or any
Just
other
keep getting
Pythagorean
multiple.
triple. Stop discriminating against 5, 12, 13. That's the best one.
Yay! Yeah, it's infinite. Infinite. We actually didn't go over it in the slides. In the slides, it was like back here. Yeah, but we didn't go over it because
All right. Last one, right?
yes, everyone got that right. Okay. Last one. Square has a side length of 4 square root of what's the length of its diagonal?
It's not the last one. There's one more slide after this.
Yeah, there's still one more after this. Did I
Just
hear
yes.
cat?
Because no, that was a door opening.
Okay. I was gonna say, like, okay. It sounded so much like a cat though.
Well, I don't have a cat and I'm not at home, so
Yeah. Yeah, for this one, you multiply by square root of 2. So it looked like some of you guys saw 8 square root of 2. I feel like you might have clicked a little bit too fast because you saw the 8 and you thought, oh, I need to multiply by square root of 2. So you clicked 8 square root of 2. But it's actually just 8.
Is anyone in sixth place? Because I've gone like 5 wrong in a row.
actually you wanted
Rishabh, get the last one wrong.
me get the last one wrong. Okay, sure.
Yeah.
I'll put false.
Well, then you just gave everyone the answer.
Everyone knows the answer.
Hopefully.
I'll give it to them for free because I'm the best teacher. Right, guys?
Well,
Yeah.
I mean, we got 6 points for putting that in the Google Classroom. So
Exactly. Right. Well, that was last week, though.
what about this week?
Well, this week, maybe, quite possibly.
You get 10
I got
points
it
if you
wrong.
put us
Oh,
both.
no, I
No,
got
it's 6 points
wrong.
per team. No,
This
you can't.
is so sad. I got it wrong.
Oh no. Wait,
Oh,
what other person put false?
I told you guys the answer. I told you the answer. I literally, I still got first.
Okay, nice job,
Yeah.
Edvika. You got 3rd place. Oh wow, Monique, you got to less, but you still got 2nd. Okay, that means you're a fast clicker. Okay, good job, Joe.
Oh,
Wait,
guys,
but then
that was
Vishwas.
wrong
Wait,
intentionally, by the way. So I actually got a perfect score. I just want to clarify that. Let's go.
wait,
I'm-
Rashab, are we giving the 4th place person 3rd place prize?
No, they didn't beat me.
All right, fine. Okay.
Yay.
Well, that doesn't make sense.
All right, well, bye.
Bye, everyone.
We're done? Oh,
Bye.
Thanks for a great class.
how many points do we get if we are 3rd? You get
1, right?
two. No,
2? Or it's 2. Okay.